Okay, this is the second part of the lecture on sound waves, and we were just talking about the power contained in a sound wave as energy per unit time. People don't actually measure the power so much as they measure a thing called the intensity, which is the power per unit area. So that's got both time and sort of area in it. And the reason for that is as a wave goes by, the area may change. And so the intensity may change. What we hear as terms of loudness is really the intensity. Depends on the amplitude, of course. The square of the amplitude, as we saw earlier. The unit, think of sound as a point source, then you can imagine these spherical waves that are emitting, coming out, and the radius of a sphere, R, then the energy is going to fall off as the surface area, which is 1 over R squared, which is what we have here. So if the area is spread out over an area of a sphere, then that's 4 power squared. So the intensity is the average power, which is going to be the same as it spreads. So the intensity is going to go down, follows an inverse square law. Now the way people measure that is with a scale named after Alexander Graham Bell, because that's one of the things that he studied, and is called the decibel. The Bell really is a ratio of a given intensity over the reference intensity, which is the average quietest sound a person can hear. Our ears are amazing. They can hear down to 10 to the minus 12 watts per meter squared, all the way up to about a watt per meter squared before it starts to actually cause discomfort. So that's a magnitude of 10 to the 12th. That's huge. So, but when you're dealing with numbers like that, over that range, it's better to deal with the exponent. So people, remember, logs are exponents, so people deal with the log. So your I naught is this 10 to the minus 12. So if you take your intensity over I naught, take the log, and then it's a decibel, so that's a 10, so you multiply that by 10. So we're going to measure sound intensities in decibels. So there's our reference, I naught. You're going to want that in, well, you don't need a formula sheet this time, do you? But you'll want that in working problems. The threshold of pain then is about 1 watt. So if you take 1 over 10 to the minus 12, that's 10 to the 12. Take the log base 10. Now this is log base 10, not ln. Log base 10 of 10 to the 12th is 12 times 10 gives you 120 decibels. So your range is about 120 decibels. If you put in I naught to that equation, you get log of 1, which is 0. So what is the sound level corresponding to an intensity of 2 10 to the minus 7 watts per meter squared, which is a reasonable sound? Well, here's how you plug it in. There's your I. Here's your I naught. That'll give you a number, 2 tenths to the 5th. You take the log base 10 of that, take that number, multiply by 10, and you'll get 53. Turns out that any change in decibel of about 3 is going to be a twice as loud. So if I go from 10 to 13, 13 is about twice as loud as 10. There's some numbers in decibels. Threshold of hearing, 0. Whisper, conversation, power more, rock concert. And I like to say here, there's a reason a lot of those rock stars from the early days are deaf, partly deaf as they get older, quicker than most of us, is because in such loud environments, it does sort of damage your ears after a little time, and 120 is right around what you can normally stand. Sound level and decibels, there's also a psychological aspect to things, and there's the response curve of our ears. Sound's both physical, but it's also a psychological. So two sounds that ought to be the same loudness to us won't necessarily, even though they measure the same. Here's a picture of a sound level versus frequency, and they've kind of outlined what you can hear. And that curve there is, our ears aren't equally sensitive to every frequency, and that varies from individual to individual, and it changes as you get older. And so some frequencies you can hear at lower levels than others. As you get older, you lose. I've lost certain frequencies in the high range. There are certain sounds that people around me can hear that I just simply don't hear anymore. And that's not unusual as people get older. But that's the decibel. scale. And I'll work some problems and post them up there on Canvas as work problems later. Okay, see you in the next video.